All right, so welcome to the chapter on recursion, or the puzzle chapter. This is possibly the most fun chapter of the book and of our curriculum right now. So this is a video for week 7, and recursion will be featured in chapter 5, obviously, but also it will be used in when we go through trees. And understanding recursion is basically the key to whether or not you're going to have an easy time with the programming that's coming up in Chapter 6. Recursion is an extremely powerful tool, and it's vital that you understand how to do it as a programmer. It's powerful. It makes easy problems so much it makes harder problems so much easier to run, and it makes your code readable and elegant. It's extremely powerful, and it looks like magic when. We're going to learn how. So first, we need to learn how to think recursively. That's kind of just how does the recursive problem-solving method work. We're also going to learn how can we just kind of verify that it's going to work. We've got to learn how to be able to follow recursion and recursive method calls down. All right, we need to be able to learn how to write recursive algorithms, and we're going to apply that on searching for arrays. We're going to start, by the way, by going over recursive algorithms to do mathematics, and then a couple of make work examples that you wouldn't actually use recursion for, but demonstrate how the process works. Then we're going to apply that to recursive data structures. We're going to go over the linked list class again, but as a recursive data structure. We're going to then next chapter, once we're done with this chapter, we're going to attack binary search trees, which are, if you can program recursively, it's easy. If you can't, it's going to be very difficult. And what do I mean by easily? Well, on the exam, you're going to have problems that can be solved recursively. On exam 2, you're going to have problems that can be solved recursively. And if you can solve them recursively, then you're going to be able to solve those problems in about 3 to 4, in about anywhere between 3 to 7 lines of code, including the braces. And if you can't solve them recursively, you're going to, I haven't seen a student solve it yet without using recursion, to put it bluntly. So it's vital that you understand it, if for no other reason than getting a good grade in the class. But recursion is this powerful tool, and you can't really go forward without understanding it. So now, another thing that we'll be using recursion for is to solve puzzles. So specifically, we'll be going over this guy in class as an in-class exercise, the Towers of Hanoi, which is a really fun puzzle. And the algorithm, once I show it to you, it looks like it should not work. It looks too simple, but it does. And then we're going to look at basically how we can, this recursive backtracking process works. So we're going to re-examine mazes again, and your homework, which I've already posted for you, goes over recursive backtracking, which is this extremely powerful problem-solving tool, which you'll use to solve some classic computer science puzzles, such as the 8 Queens puzzle, and using it to write a Sudoku puzzle. One thing that I'm going to make sure I go over that doesn't get covered by this book is also using recursion to generate permutations. So I'm going to try my best to make sure I cover that. And again, it's saying here that it makes many programming problems which are difficult to conceptualize. It's difficult to think of how to solve them. Recursion helps you solve them. And how does it work? Essentially, the way it works is that it takes a problem and breaks it down into a smaller problem, saying, oh, this big problem is way too tough. So if I'm going to just solve this little bit, and I'm going to break it down into the problem into a smaller version of itself. So we're going to see what that means in a short bit with the factorial function, which is the first one I want to go over. Another way to think of it is this Russian nesting doll kind of idea, which is basically that each problem, that basically inside each Russian nesting doll is a smaller doll until we get to a doll we can't open anymore. Each doll is less intricate than the next. It's less complicated until we get to a very, very simple doll in the middle. So we will go ahead and start with, rather than going through what the book thinks as the good examples to go through, I'm going to go and talk about the factorial function in our first actual video on the topic. So we'll start here in another video.